Assalamualaikum. Today we are going to solve May-June 2023 P1 variant 2. The code is 9709. In our question number 1, examiner says the equation of a curve is such that dy by dx equals 4 over x minus 3 whole cube for x is greater than 3. The curve passes through the point 4, 5. Find the equation of the curve. So dy by dx is given, so we can write it as y equals integral of 4 over x minus 3 whole power 3 dx. Because integration is the reverse process of differentiation, so we have to go reverse. Now remove the denominator, like y equals integral 4 times x minus 3 whole power negative 3 dx. Now it's ready for integration. So we can say y equals 4 is a constant value. X minus 3, you add 1 in the power and divide it by the same minus 3 plus 1 plus c. Actually, I should have divide by the differentiation of x, which is 1. So no need to do that because the answer is 1 for this. So y equals 4 x minus 3 power negative 2 over negative 2 plus c. Y is equal to 4 into, you can bring the negative sign also with 2. So it's 2 over 1, so its reciprocal is 1 over 2. And x minus 3 whole power minus 2 plus c. Now 2 2s are 4, so this will become y equals negative 2 over. So make this bracket positive by bringing it down, x minus 3 square plus c. Now we have to find the value of c. He has given us the coordinates through which the curve is passing, 4, 5. So 5 in y and 4 in x. Simplify it. 5 equals minus 2 over 1 plus c. So this is 5 equals minus 2 plus c. So 5 plus 2 is equal to c. So c is equal to 7. Put this value back into the equation. So y equals minus 2 over x minus 3 whole square plus 7. So this would be our answer. Move on to question number 2. The quotient of x power 4 in the expansion of x plus a power 6 is p, and the quotient of x square in the expansion of ax plus 3 whole power 4 is q. It is given that p plus q is equal to 276. Find the possible values of the constant a. So we have to use specific term formula. And that is NCR a power r b power n minus r. So for x plus a whole power 6, I can use this formula on that. So 6CR x power r a power 6 minus r. So Now collect the x terms only. So x power r and equate it with x power 4. Because we need to find the quotient of x power 4, that's why I have equated this x power r with x power 4. So basis becomes same on either side of the is equal to sign, so I can write now r is equal to 4. Now you replace r by 4, 6e4, x power 4, a power 6 minus 4, and this will give you 6e4, x power 4, and a power 2. And the now coefficient of x power 4 is 6c4 a power 2, which is 15a square. 6c4 is 15. We can write p is equal to 15a square. As he said in the question, p quotient of x square is p. So make it equation number 1. Now work with ax plus 3 whole power 4. Again we are going to use specific term, which is NCR, a power r, b power n minus r. So here here n is 4, 4cr ax power r, and over b is 3, so 3 power r. Again collect the x terms, so I can write x power r and equate it with x square, because we need to find the quotient of x square. So from here our r equals 2, because the bases on the either side of is equal to sign are same. So now put this value of r in the equation. 4c2 ax power 2 3 power 2. So the quotient of x square would be 4c2 a power 2 3 power 2, and this becomes 6 a square 9, which is 54a square. We can write now q equals 54a square, and this becomes our equation number 2. And given in the question, he said p plus q equals 276. So we have p 15a squared plus q is 54 a squared is equal to 276, and by simplifying we get 69 a square is equal to 276. So a square would be equals to 276 divided by 69, which is 4. So a would be equals to 4 square root, so a would be equals to plus minus 2. This is the answer for this question. Question number 3. Express 4x square minus 24x plus b in the form a times x plus b whole square plus c, where a and b are integers and c is to be given in terms of the constant p. Okay, so let's write 4x square minus 24x plus b, and The quotient of x square should be 1. So take 4s common. Now you will get x square minus 6x plus p over 4. Now in the next step, what you do, x square minus 6x, create a gap after 6x and write p over 4 here. Now take the quotient of x, which is 6, half it means divided by 2 and square it. These are the steps you have to follow always. So you add 3 square, you subtract 3 square. Now I can write this portion as the first is x square, the last is 3 square, and the sign I have to take sign negative, which is before 6x. So can I write x minus 3 whole square for this part and solve this separately? So you will get negative 3 squared plus p over 4, so which is minus 9 plus p over 4. Take the LCM 4, so minus 36 plus p, and this becomes p minus 36 over 4. We can write this here, plus p minus 36 over 4. Now multiply this 4 with the bracket like that, x minus 3 square, plus now multiply 4 with this p minus 36 over 4, so you will be left with p minus 36. So this is actually in the form which he needed, a times x minus p whole square plus c. So this is your answer. B part says, hence or otherwise find the set of values of p for which equation 4x square minus 24x plus p equals 0 has no real roots. Okay, so 4x square minus 24x plus p equals 0. For no real roots, I have to write the discriminant b square minus 4ac less than 0. My a equals 4, my b equals negative 24, and my c equals p. So negative 24 squared, negative 4 times 4, and p less than 0. So this is 576 minus 16p less than 0. So 576 less than positive 16p. And I can write 16p is greater than 576. Now p is greater than 576 divided by 16. So p is greater than 36. This would be our answer for this part. Question number 4. Solve the equation 8x power 6 plus 215 x power 3 minus 27. So you let y is equal to x power 3. So then we can write x power 6 can be written as y square, because y equals x power 3. So x power 3 whole power 3 will make x power 6. So now you write this whole equation in terms of y. So I can write 8y square plus 215y minus 27 is equal to 0. Now midterm breaking, so 8 into 27 is 216. I have to make factors of 216 so that those factors, if I add and subtract, I should get plus 215, which is in the middle. So this is 216 times 1 is 216, and 216 minus 1 gives me 215. So I will use 216 and negative 1. So 8y squared plus 216y minus y minus 27 is equal to 0. So take common from the first two expressions. So my 8y is common. I can write y plus 27 minus, and from last two expression I can take 1 as common. So minus minus plus 27 equals 0. So my one bracket is 8y minus 1 and other is my y plus 27. So these are the two factors. So 8y minus 1 equals 0, and from here y plus 27 equals 0. So from here y is equal to 1 by 8, and from here y is equal to negative 27. So replace y by x cube because we let it as x cube. So x cube is equal to 1 over 8. So x would be the cube root of 1 over 3, which is 1 over 2. And from here, replace y by x cube equals negative 27. So x would be equals to cube root of negative 27. So x would be equals to negative 3. So these are our two answers. Question number 5. The diagram shows a curve with equation this: for x greater than 0, curve meets the x-axis at the point 0, 0 and 4, 0. Find the area of the shaded region. So to find the area of the shaded region, we have to integrate by writing the limits, and limits are from 0 to 4. So 10 x power 1 by 2 minus 5 by 2 x power 3 by 2 dx. So integration would be 10 x power, you add 1 in 1 over 2, so you get 3 by 2, and you have to divide by the same 3 by 2, minus 5 over 2 is a constant value. X power, you add 1 in 3 over 2, so you get 5 by 2, and divided 5 by 2. Now put the limit at the end, and that is from 0 to 4. Let us first simplify inside the bracket. So 10 times 3 over 2 in the denominator will become 2 by 3, x power 3 by 2, minus 5 by 2 times the denominator 5 by 2 will become 2 by 5, x power 5 by 2. From 0 to 4. Okay, this is 20 by 3, x power 3 by 2, minus x power 5 by 2, and limit is from 0 to 4. So now upper limit minus lower limit. Wherever you see the x, you place 4, which is your upper limit. So 20 by 3, 4 power 3 by 2 minus 4 power 5 by 2. This is our upper limit minus lower limit. So we have to put 0 in x. 20 over 3, 0 power 3 by 2 minus 0 power 5 by 2. So this all will become 0. This side only I have to simplify the first bracket, which is 160 over 3 minus 32, and this will become 64 over 3, or 21 whole number 1 by 3. Question number 6. The diagram shows a sector OAB of a circle with center O. Angle AOB equals theta radian and OP equals AP equals x. Show that the arc length AB is 2x theta cos of theta. So I should make a right angle triangle here, because OP and AP are the same length, like it's written x here, so I can make a drop and it will divide O in equal parts. So from here, can I write cos of theta OM, write it as M, this point. So can I write cos theta equals OM over x, and this gives me OM equals x cos theta. Now OA would be equals to 2 times x cos theta, because if this is x cos theta, so this is also x cos theta. So together they make 2 times x cos theta. So the formula for arc length is S is equal to r theta. So my S, which is arc length, r radius is my 2x cos theta times theta is my theta. So finally I will write S equals 2x cos, wait, 2x theta cos theta, and I can write shown. Find the area of the shaded region APB in terms of x and theta. Okay. Area of sector, the formula is A equals 1 over 2 RS, or area equals 1 over 2 r square theta. So I'm going to use 1 over 2 RS. So area is equal to 1 over 2. My radius is 2x cos theta, and my arc length S is which I just shown in the previous part, 2x theta cos theta. So this 2 and 2 gone, a equals 2x squared theta cos squared theta. Now what should we do? We have to find area of triangle OMP. Where is OM? OMP. So first find MP. MP. So MP can be found out with the help of sine theta equals MP over X. Look, if we use sine theta, it's opposite over hypotenuse. So MP over X. This gives us MP equals X sine theta. Now, area of triangle OAP. OAP. Where is OAP? You can see this. OAP, this white triangle, the big one. This is area is equal to 1 over 2 into base into height. Our base was the whole radius, 2x cos theta, times height is over x sine theta. So these 2's are gone. So area would be equals to x square sine theta cos theta. Area of shaded region APB would be equals to area of sector OAB minus area of triangle OAP. So we can write 2x squared theta cos squared theta minus x square sine theta cos theta. Now take x square cos theta as common. You can write 2 theta cos theta minus sine theta. That's your answer. Question number 7a. By first expanding cos theta plus sine theta whole square, find 3 solutions of the equation cos theta plus sine theta whole square is equal to 1 and theta is less than equal to pi greater than equal to 1. Okay. So cos theta plus sine theta whole square, you open it with the help of the identity a plus b whole square. So you can write cos square theta plus 2ab means 2 sine theta cos theta plus sine square theta. So bring sine square theta near to cos square theta plus 2 sine theta cos theta. And as we know that sine square theta plus cos square theta is 1, so we can write 1 plus 2 sine theta cos theta. Now consider the second, cos theta plus sine theta whole square is equal to 1. So this left side we have already worked with it, and we found the solution 1 plus 2 sine theta cos theta is equal to 1. So these two ones gone. You are left with 2 sine theta cos theta equals 0. So 0 divided by 2, so you are left with sine theta cos theta is equal to 0. So your sine theta equals 0 and your cos theta is equal to 0. Now we have to see where sine theta and cos theta gives us 0. So let me quickly make the graph of sine theta. This is your 0, 90. 90 means pi by 2. 180 means pi. And here is your 1. Here is your negative 1. This is 3 pi by 2, which is 270, and this is your 2 pi, means 360. So at 0 your sine is 0, and at 180 means at pi your sine is 0. Let me circle it with black color. Here your sine is 0, here your sine is 0. So two values you can write, 0 and pi. And let's quickly make the cos. This is 0, 90 means pi by 2, and here is your 1, here is your negative 1, here your 0, 180 means pi, here is your 3 pi by 2, which is 270, and here is your 360, which is 2 pi. So where your cos is 0, let me show you with a black circle. Here is your cos 0 and here is your cos 0, but this is out of the range. We have to keep up to the pi. So just you can write only one value here, and which is pi by 2. So your final three solutions are 0, pi by 2 and pi. This is the answer. Okay, second part says, hence verify that only solutions of the equation cos theta plus sin theta equals 1, theta is less than equal to pi greater than equal to 0 are 0 and 1 by 2 pi. So simple, cos theta plus sin theta is equal to 1. So from 0 to pi, so first write 0, cos 0 plus sin 0. Cos 0 is 1, sin 0 is 0. So this is 1 equals 1. So yes, means we have to pick this value 0. And now again cos theta plus sin theta is equal to 1. Now write pi by 2 sine pi by 2. So cos pi by 2 is 0 and sine pi by 2 is 1. So 1 equals 1. Right. Now try the last, cos theta plus sine theta is equal to 1, and now place pi. So sine pi. So cos pi is -1, sine pi is 0. So -1 is equal to 1, so this is discarded. So we have shown that when we place 0, we got the equation satisfied, and when we placed pi by 2, the equation was satisfied. So this is shown that 0 and pi by 2 are the only solutions of the equation. B part, prove the identity. Okay. So in the left hand side, if I take the LCM cos theta plus sin theta and cos theta negative sin theta. So now multiply it with sin theta cross multiply. So my sin theta will go with cos theta minus sin theta plus 1 minus cos theta will be multiplied with cos theta plus sin theta. Okay. Now I'm going to multiply sin theta with the bracket. So sin theta cos theta minus sin square theta plus, now multiply the two brackets. One with multiply cos theta is cos theta. Actually this will multiply by this, then this, and plus sin theta minus, now this cos theta will multiply by this and then this. So minus cos square theta minus sin theta cos theta whole over cos theta plus sin theta times cos theta negative sin theta. So these two will be cancelled. Now we can write cos theta plus sin theta minus sin square theta minus cos square theta over, if I multiply the denominator with these two brackets, I can get cos square theta minus sin theta cos theta plus sine theta minus sine square theta. So sine theta and plus sine theta minus sine theta are cancelled, and in the numerator I can take cos theta plus sine theta minus common, and I can write sine square theta plus cos square theta, so that this side becomes 1. So this cos square theta minus sine square theta. Okay, in the numerator now your equation becomes cos theta plus sine theta minus 1 over in place of cos square theta, can I write 1 minus cos square theta, 1 minus sine square theta, because we know that from sine square theta plus cos square theta is equal to 1. If I make cos square theta as subject, I can write 1 minus sine square theta. So this is what I did here, minus sine square theta. So now you can write cos theta plus sine theta minus 1 over 1 minus 2 sine square theta, which is your right hand side. So proved. Using the result of A2 and B, solve the equation this for theta is less than equal to pi and greater than equal to 0. Okay. We can replace the left hand side with the result in part B. So I can write cos theta plus sine theta over 1 minus 2 sine square theta. Okay, let's see our result in part B. This is our result in part B. Cos theta plus sine theta minus 1 over 1 minus 2 sine square theta. Okay, now this is equal to 2 cos theta plus sine theta minus 1. Now bring all this to the left hand side. Cos theta plus sine theta over 1 minus 2 sine square theta minus 2 cos theta plus sine theta minus 1 equals 0. Now take common. What? You take cos theta plus sine theta minus 1 as common. So if I write it as common, I can write now 1 over 1 minus 2 sine square theta minus 2. This is equal to 0. So now we can write cos theta plus sine theta minus 1 is equal to 0, or 1 over 1 minus 2 sine square theta minus 2 is equal to 0. For cos theta plus sine theta minus 1, you can refer to part A2. Now can I write cos theta plus sine theta? You send minus 1 over there, so this is equal to 1. And for this type of equation in part A2, we already found out two values of theta, and that was 0 and pi by 2. Let me show you. 0 and pi by 2. See? And now come to the right side. 1 over 1 minus 2 sine square theta, and send negative 2 over there. Now bring 2 down and 1 minus 2 sine square theta up. So it becomes 1 over 2 equals 1 minus 2 sine square theta. So this we can write minus 2 sine square theta, bring it here, and 1 over 2 send it there. So you can write 2 sine square theta is equal to 1 minus 1 over 2, and this will become 2 sine square theta is equal to 1 by 2. So this is sine square theta is equal to 1 over 4, and from here sine of theta would be equals to plus minus 1 by 2. So sine theta, when 1 over 2, it's positive, so ASTC, so theta is sine inverse of 1 by 2, and this is pi by 6. So your basic angle, positive sine is here and here. So your basic angle pi by 6 is here and pi by 6 is here. So in first quadrant you have to pick pi by 6, and for the second quadrant you have to subtract pi by 6 from pi. So pi minus pi by 6 is 5 pi by 6. So these two results we can take it from the positive sine theta, which is 1 over 2. Now 1 was over negative 1 over 2. So sine theta is equal to negative 1 over 2 means ASTC. Our sine is negative in this quadrant and in this quadrant. Basic angle is same, pi by 6 here and here. Basic angle is always made with the x-axis. You have to remember this point. So if we calculate this any value of theta here clockwise, so this would be not in the range from 0 to pi, so only these two answers are valid. So put these two values in your answers. Question number 8. The diagram shows graph of y is equal to f of x where the function f is defined by this. On the diagram, sketch the graph of y is equal to f inverse of x. Okay, so you have to make first y is equal to x line. This is your y is equal to x line. Remember that always whenever examiner wants us to make inverse, we have to make that inverse always in y is equal to x line. So carefully you reflect the points. Okay. I think it's not good enough. Almost like this. Find an expression for f inverse of x. So let y is equal to f of x. Now write the equation with y. Y equals 3 plus 2 sine 1 over 4x. So now try to make x the subject. So 2 sine 1 over 4 x is equal to y minus 3 sine 1 over 4 x is equal to y minus 3 divided by 2. Now 1 over 4x is equal to sine inverse of y minus 3 over 2. Now x is equal to 4 sine inverse of y minus 3 over 2. Now you can write f inverse of x equals 4 sine inverse of x minus 3, replace x y by x. So this is your inverse. Okay, in part C, the diagram above shows part of the graph of function g of x is equal to this for x is less than equal to 2 pi greater than equal to minus 2. Complete the sketch of the graph of g of x on the diagram above and hence explain whether the function g has an inverse. Okay, so you can find out the values like put the value of x one by one in from pi to 2 pi to negative 2 pi. So actually from 0 to negative 2 pi you have to put the values in the main equation, like suppose y is equal to 3 plus 2 sine of 1 over 4x. So suppose if I put the value minus half pi, x is equal to minus half pi here, so I will get 2.23, and next y is equal to 3 plus 2 sine of 1 over 4x, and now if I put x is equal to minus pi here, I will get the value 1.59. Then minus 3 by 2 pi, and then if I put x is equal to minus 3 by 2 pi, I will get the value, now I am writing it directly, 1.15. And when I will put x is equal to minus 2 pi, I will get the value 1. So carefully, 2.23 is somewhere actually you correct it. It is not the value of minus pi by 2. This is the value of negative pi here when I place negative pi. So at negative pi it is 2.23, which is a little below pi. Somewhere here, I think. Somewhere here. Or maybe, wait. Okay, let's start from 1. When negative 2 pi, it was 1, and it is just above here. Then 1.59, this one. And this was little below pi by 2. And over negative 3 pi by 2. Negative 3 pi by 2. This is negative 3 pi by 2. Let me correct it. And then 1.59. Okay, this is negative 3 pi by 2. Negative 1.5. Then, sorry, this is negative pi. Okay, negative pi by 2 is done. Then negative 3 pi by 2 is done. Now comes negative pi. This is actually negative pi by 2. And this is negative pi. Now it's okay. So when negative pi 1.59, which is a little above pi by 2, here. by 2 and we got the value 2 point something here. Now you can join these points. So this is the sketch of the graph. Now we have to answer him. Yeah, you can say yes, it has an inverse. Because it is one-to-one function. If you make a horizontal test line, see these horizontal lines are cutting the whole graph from only one point. So when the horizontal lines cut the graph from only one point, then that graph must have an inverse. In part D, question says describe fully a sequence of 3 transformations which can be combined to transform the graph of y equals sin of x for x is less than equal to half pi and greater than equal to 0 to the graph of y is equal to f of x, making clear the order in which the transformation are applied. So for this part, let me write the question first. It's 3 plus 2 sine of 1 over 4x. So I will say that first it's a stretch and factor of 4. Actually this 1 over 4 will become 4. We always take the reciprocal in x direction. Always start with the stretch in x direction. So sine of x turns into sine 1 over 4x. Secondly, it's again a stretch and factor of 2 in y direction. So our steps starts from in the direction of x, then we will see where is the y direction, and it is always the quotient of sine of x, which is 2 here. So this 2 is actually the stretch factor of 2 in y direction. So sine of x, sine of 1 over 4x turns into 2 sine of 1 over 4x. Lastly, it's a translation and x is 0 and y is 3, which makes the whole equation like 2 sine of 1 over 4x plus 3. So this 3 is actually, let me circle it with black, this 3 is the translation. It moves the whole curve up or down. So here we complete this part. Now move on to question number 9. In this question, the question says the second term of geometric progression is 16 and the sum to infinity is 100. Part A, find the two possible values of the first term. So formula for sum of infinity is sum of infinity equals A over 1 minus R. Okay, the second term we can write as AR, and AR equals 16, it's given. Actually, let me further explain it. Our first term in GP, geometric progression, is A. Our second term in GP is AR. Our third term in GP is AR square, and so on like that. So from here, if I make R the subject, so I can write 16 over A. Okay, come back to sum to infinity. My sum to infinity is 100, which is given in the question. 100 equals A over 1 minus R. And now I will cross multiply this. 100 times 1 minus R equals A. And 100 times 1 minus, my R is 16 over A, and this is equal to A. Now our simplification will start from here. 100 minus 1600 over A equals A. So my LCM is A here. So 100A minus 1600 equals A. So A will be multiplied by the A there, so it becomes A square equals 100A minus 1600. So if I bring all the things to A square, it will become A square minus 100A plus 1600 equals 0. And this becomes a quadratic equation, so midterm breaking. So my factors would be A minus 20 and A minus 80 equals 0. So from here A equals 20 and A equals 80. These two are my answer, and A is our first term. B part says, show that the nth term of one of the two possible geometric progressions is equal to 4 power n minus 2 multiplied by the nth term of the other geometric progression. So let's do it. My R equals 4 by 5 or 1 by 5. If you use the values of A, which was 20 and 80, in here R equals 16 over A. So R equals 16 over A. Let me write it here. R equals 16 over A, and my first A was 20, so 16 by 20. So 16 by 20 gives me 4 by 5. And my second value for A was 16 by 80. And this gives me 1 by 5. That's how we got the value of r. So we know that the nth term for a geometric progression is a r power n minus 1. So first we will try 20. So in a, so 20 times r is 4 over 5 whole power n, and sidewise I can write Tn equals, I will use 18a, the second value of a, times 1 over 5 power n minus 1. Okay, use this one, work further on this. Tn equals 80 times 1 over 5 whole power n minus 1. So 80 times 1 over 5 whole power n minus 1 times 4 power n minus 2, and this will become 80 1 over 5 whole power n minus 1 times, I can change 4 power n minus 2 like 4 power n divided by 4 square. Actually this is the indices rule. If you have 4 power n divide 4 power 2, so bases are same and they are dividing, so it will become 4 power n minus 2. So I split it backwards. So now can I write 80 1 over 5 power n minus 1 times, can I write 4 power n over 4 times 1 over 4, it's the same thing, 4 square. So this 4 will simplify 80 by 20, so it becomes 20 1 over 5 whole power n minus 1 times 4 power n minus 1. So now we can write it like this, 20 times 4 over 5 whole power n minus 1, which is shown. Question number 10. Okay, the equation of a circle is x minus a whole square plus y minus a whole square is equal to 20. The line y equals 1 over 2x plus 6 is a tangent to the circle at the point P. Show that one possible value of a is 4 and find the other possible value. Okay, our equation is, x minus a whole square plus y minus 3 whole square is equal to 20. So my equation is y equals, straight line equation is y equals 1 over 2x plus 6. So I will replace this in y. In this y I am going to write 1 over 2x plus 6 minus 3 is equal to 20. So this becomes x minus a whole square plus 1 over 2x plus 3 whole square equals 20. Now open these brackets, so it becomes x square minus 2ax plus a square plus, Now open the second bracket, it becomes 1 over 4x squared plus 3x plus 9 is equal to 20. Okay, no need to put the bracket here. Now let's simplify this. The like terms, if you see like term, one is x squared, other is 1 plus 1 over 4x squared. So this will become 5 over 4x squared minus 2ax plus 3x plus a squared minus 11 equals 0. So this portion, this one, can I write like this, 3x minus 2ax, and from here I'm going to take x common, so it becomes 3 minus 2a. So now use b square minus 4ac, that is the discriminant, and this should be equal to 0. Why it is equal to 0? Because in the question he says the equation of circle and the line is tangent to the circle. So whenever the line is tangent to the circle, our discriminant is always equals to 0. So my a is equal to 5 over 4 and my b equals 3 minus 2a and my c equals a square minus 11. Place the values in b square minus 4ac carefully. So 3 minus 2a square, this is b square, minus 4, and our a is 5 over 4, and our c is a square minus 11. This is equal to 0. So these two 4's are gone. And now open 3 minus 2a whole square, so it becomes 9 minus 12a plus 4a square minus 5a square plus minus into minus plus 55. 5 multiplied by 11 is 55 equals 0. Further simplify this, so you will get minus a square minus 12a plus 64 equals 0. So divide by negative, you will get a square plus 12a minus 64 equals 0. Again, we have got the quadratic equation, so by solving it, by factorizing it, we will get a plus 16, a minus 4. So my a equals negative 16 and my a equals positive 4. So this is already there. So no need to use this. So my final answer would be a equals minus 16. In our b part, for a equals 4, find the equation of normal to the circle at P. So let me make a small diagram for it. Suppose this is my circle and I make a normal over here. So our coordinates of center is 4, 3, and my equation was y equals 1 over 2x plus 6. So m is gradient of tangent equals 1 by 2 the coefficient of x is 1 by 2. So gradient of normal would be opposite or reciprocal of this. Opposite of plus is negative and reciprocal of 1 over 2 is 2. So minus 2 is the gradient of the normal. So use y minus y1 equals m times x minus x1. So y minus y1 would be over 3 and m is over minus 2, x minus 4. Now y minus 3 equals minus 2x plus 8. So y equals, or you can turn negative 2x into positive. So you can write y plus 2x is equal to 8 plus 3. So finally you will get y plus 2x equals 11. This is your answer for this part. Your part C, for a equals 4, find the equations of two tangents to the circle which are parallel to the normal found in B. So let me make a small diagram for the concept. Suppose this was our tangent, radius, and this was our tangent here. So this is our normal to the tangent, this is tangent to the circle. So I have to make two tangents which are parallel to the normal. So one goes from here and other goes from here. These are tangents which are parallel to the normal. Okay. So let's do it. Y minus 3 equals 1 over 2 x minus 4. Remember our coordinates 3, 4. So our m of initial tangent, our initial tangent is red. So it's this was our initial tangent and its gradient was 1 by 2. That gradient I'm using here. So from here my equation becomes 2y minus 6 is equal to x minus 4 and 2y equals x plus 2. This is further actually the equation of the diameter. This is a diameter. This is the equation of diameter. So if I divide 2, the coefficient of y on the other side, x plus 2, so my equation will finally look like this: y equals 1 by 2x plus 1. Okay, now write down the equation of circle plus y minus 3 whole square is equal to 0. And now put the value of this y here in the equation of the circle. 1 over 2x plus 1 minus 3 whole square equals 0. So now open it. X square minus 8x plus 16 plus okay, do not open this one. 1 over 2x minus 2 whole square equals 0. Okay, let's open it here instead of taking another line. So it will become 1 over 4 x squared minus 2x plus 4. Actually this is 1 minus 2 is 1 minus 3 is minus 2. So let me correct this one. Sorry, this one will become minus 2. Okay, one more thing I have to correct it here, and that is I have not to write zeros. This is actually 20. Okay, actually I was saying where by mistake I wrote it 0 instead of 20. So now further by simplification I can get 5 over 4x squared minus 10x and equals 0. So if I take x as common, so my factors would be one factor is x, other is 5 over 4x minus 10 equals 0. So my first x is equal to 0, my second x is 8. Now let me change the color. You put in the straight line equation y equals 1 over 2. First you put 0 and you will get 1. Y equals 1. Other, you put 8 in the same equation in x and you will get 5. So your coordinates would be 0, 1 and 8, 5. So now y is equal to, y minus 1 equals minus 2, x minus 0. From here your equation is y is equal to 1 minus 2x and other y minus 5 equals minus 2 x minus 8, and from here if you simplify it your equation is y is equal to minus 2x plus 21. So these are the equations of the two tangents. In our question number 11, the equation of a curve is this, where k is a positive constant, find dy by dx. So you write y equals k times root of 4x plus 1 minus x plus 5. So your dy by dx is, so k times 1 over 2 4x plus 1 whole power minus 1 over 2 into, we have to write the differentiation of 4x with this, which is 4. and then minus 1, which is a differentiation of minus x. No differentiation of 5. This is a constant value, so its differentiation is 0. So 2 times 2 is 4, so then it becomes 2k 4x plus 1 whole power minus 1 over 2 minus 1. So this is the dy by dx, or you can also write 2k over 4x plus 1 whole under the root minus 1. Find the x coordinate of the stationary point in terms of k. So as we know, at stationary point the dy by dx is always equal to 0. So can I write 2k over 4x plus 1 square root minus 1 is equal to 0, because this was differentiation part. So 2k minus 4x plus 1 under root over 4x plus 1 under root equals 0. I took the LCM, so this denominator will multiply by 0 and it will be no more. So we can write 2k minus 4x plus 1 under root is equal to 0. Now what should we do? So 2k is equal to positive 4x plus 1 under root. Now squaring both sides. So it will become 4k square is equal to 4x plus 1. Square will cancel the square root. So 4x is equal to 4k square minus 1, and x is equal to 4k square minus 1 over 4. This is our answer for this part. Part C, given that k is equal to 10.5, find the equation of normal to the curve at the point where the tangent to the curve makes an angle of tan inverse of 2 with the positive x-axis. Okay, so let me explain something here. Tan inverse of 2 means theta is equal to tan inverse of 2. So from here I can write tan theta is equal to 2. And remember, tan theta is always dy by dx, means gradient. So it means I can write dy by dx is equal to 2. So now you can write 2k 4x plus 1 whole power minus 1 by 2 minus 1, and put the value of k in it, which is 10.5 given. 4x plus 1 whole power minus 1 by 2 minus 1 is equal to 2. So 21 4x plus 1 whole power minus 1 by 2 minus 1 is equal to 2. So 21 4x plus 1 whole power minus 1 by 2 is equal to, this minus 1 will go there, so 2 plus 1 is 3. So 4x plus 1 whole power minus 1 by 2 is equal to 3 by 2. 3 by 21, sorry. So which is 1 by 7. And now I can write it like that. 1 over 4x plus 1 whole under root is equal to 1 by 7. So cross multiply, it will become 4x plus 1 under root is equal to 7. Now square both sides. So by squaring, your square root will be gone and it becomes 4x plus 1 is equal to 49. And from here, your x would be equals to 12. So as we know that m of normal equals minus 1 by 2. So y is equal to k times 4x plus 1 whole under root minus x plus 5. So y is equal to 10.5, and for in x you write 12, which you just found out, plus 1 minus 12 plus 5. So your y is equal to 66.5. And you can say that y minus 66.5 equals minus 1 over 2x minus 12. Actually, this is the same general form of equation which we use to find out the equation of y minus y1 equals m into x minus x1. So when you simplify this, it will become 2y equals minus x plus 25. You can leave this as it is. It will be accepted by the examiner. So that's it. Finish with this paper. My number is Thank you.